We're all completely blown away by what AI can do, right? But it's got this huge secret that's kind of hiding in plain sight. It has an absolutely massive appetite for electricity. So today, we're going to pull back that curtain and ask a really, really big question. Can our planet actually afford the power bill for this AI future we're all so excited about?
Okay, take a good long look at this number, 1,500 terawatt hours. And no, that is not a typo. That's the projection for the yearly electricity demand for AI data centers by the year 2030. It's a number so big it almost doesn't feel real, but believe me, it represents a very real challenge that's coming at us, and it's coming at us fast.
And right there, that creates a huge conflict. On one hand, you have this incredible, world-changing technology. On the other, well, a global power grid that has some very real limits. So that's the big question we have to tackle, isn't it? Can we actually fuel this AI revolution without, triggering blackouts or straining our infrastructure to the breaking point or even accelerating an environmental crisis?
All right, so to really get our heads around this challenge, we first need to understand the sheer scale of this power demand. And the best place to start is, well, where are we right now? So, back in 2023, all the data centers in the whole world, and I'm talking about everything, not just AI, used up around 500 terawatt hours of juice. Now that's already 1.5% of all the electricity on Earth. And here's the kicker. That was before this whole generative AI explosion really truly kicked into high gear. Okay, so what even is a terawatt hour? I mean, it sounds big, right? Well, it is. It's a colossal amount of energy. To put it into perspective for you, just 1 terawatt hour is enough to power a city the size of San Francisco for an entire year. So when we start talking about hundreds or even thousands of these, yeah, the scale is just absolutely mind-blowing. All right, now check out this comparison. That 1,500 terawatt hour number we've been talking about, the projection for AI alone in 2030, that's almost 4 times the amount of electricity an entire industrialized country uses in a year. We're not just talking about a small bump here. This is a complete reshaping of who's using the world's energy. So, what's behind this crazy, unquenchable thirst for power? The growth has been, frankly, insane, and it looks like it's only speeding up.
Okay, this timeline really lays it out. Look at this. Data center energy use doubled in just 4 years, from 2015 to 2019. Now, jump ahead to 2027, just the AI servers alone could be asking for over 85 terawatt hours. And get this, the US demand by itself is projected to triple by 2030. This isn't a gentle slope, people. This thing is going parabolic. And the main culprit, the thing at the heart of this whole power surge, it's these GPU-heavy servers. The graphics processing units, or GPUs, they're the real engines of AI. They're built to do thousands of calculations all at the same time, which is what makes them so powerful. But it also makes them incredibly power-hungry. We're talking way, way more electricity than the regular old CPUs that run most of the internet we know. So yeah, AI's brain is built on a really, really hungry foundation. Okay, so the demand is exploding. We get it. But what about the other side of this, the supply side? Is our global power grid ready for this kind of shock? I mean, is it even close? So this is kind of like our global power menu for 2026. And there's some good news, right? Renewables are on track to be the biggest slice of the pie. But, and this is a big but, here's the reality check. Fossil fuels, coal, natural gas, they still make up more than half of all our electricity. So we're basically trying to power this super futuristic technology with an energy system that's, well, pretty old school. Now, the world is absolutely scrambling to fix this. A mind-blowing $2.2 trillion is set to be invested in clean energy in 2025 alone. That's a massive push to build new clean capacity. But here's the thing. With AI's demand just getting steeper and steeper, the big question is, can we actually build it all fast enough? And this is where it all comes to a head. It's the central conflict of this whole story. You've got this runaway train of AI power demand, and it's on a collision course with a global energy supply that's already stretched pretty thin. This really is the tension right at the heart of it. On one side, you've got AI's endless appetite, driven by those power-sucking GPUs and the explosion of data centers everywhere. And on the other side, you've got our current energy supply, which is still leaning heavily on fossil fuels, dealing with constant delays in grid upgrades, and, as you've probably noticed, it's already making electricity prices go up for all of us. This quote just hits the nail on the head. It perfectly captures how fragile the situation is. It's like we're walking a tightrope. Our power grid can handle what we need today, but just barely. There's almost no wiggle room. It is absolutely not ready for a giant new source of demand like AI to just get dropped on top of everything else. And look, if we can't fill this gap with clean energy, the environmental cost is huge. We're talking about a potential 1.7 gigatons of extra CO2 pumped into the atmosphere by 2030. To give you some context, that's more than the entire global airline industry puts out in a year. It would be a gigantic step backward for our climate goals. So this is not a simple problem with a simple fix. Not at all. It really forces us to face some tough choices. And not just about how we power AI, but about what kind of future we actually want to build. Yeah, there's no magic wand we can wave here. The only way forward is to do, well, everything. It's a huge puzzle. We have to tackle it from the demand side. That means building smarter, more efficient AI. And then from the supply side, we've got to optimize our power grids, go all in on renewables, maybe even give nuclear power another serious look, and just keep innovating new ways to make clean energy. And that really brings us to the bottom line. The key takeaway from all of this: we can't have the AI revolution without an energy revolution to go with it. They have to happen together. If we want all the amazing things AI promises, then we have to be just as ambitious and just as fast with changing how we make and move clean power. The two are completely tied together now. You can't separate them. Which leaves us with one last really important question to think about. The promise of AI, it's incredible, no doubt. But the price tag is just as real. And we're measuring it in gigawatts and tons of carbon. So as we're all racing into this new future, we really have to ask ourselves, are we building a future that's truly intelligent or one that's just unsustainable? That's the choice we have to make.
The biggest question that has to be answered is who pays for all these upgrades to the power grids around the world?